We are now getting ready to listen to Jennifer Reif. Are you ready, Jennifer?
Yes, I'm ready.
Did I say your last name correctly?
It's Reif.
Reif. I apologize.
No, that's all right.
You're allowed to mispronounce my name anytime. All right.
So, okay, that's fair.
So everybody give her a virtual hand to Jennifer. She's going to be talking about developing applications with Spring and Neo4j.
Okay, let me see if I can share my screen here. That one. Okay, hopefully everybody can see. All right, so with that, we're gonna dive right in here, and I'm gonna make sure I start my timer so I can keep an eye on that. Okay, so I'm gonna talk today about building applications with Spring and Neo4j. Just a little bit of background on me. I'm a developer relations engineer for Neo4j. I enjoy writing code, and then I enjoy kind of sharing that code in a variety of ways. I like to learn, which most of us probably do. So conference speaking or virtual events like this, meetups, blogs, anything like that, I'm thrilled to do. So feel free. We do have a limited time today in this span, but please do feel free to reach out to me if you think of a question later. We have a great lineup of speakers I've seen. So if you think of it, during another presentation or later in the day or next week sometime, feel free to ping me via Twitter or email, or however you're most comfortable. Happy to continue that discussion or answer questions or point you to resources, whatever your needs might be. So today we're going to talk a little bit about what's current with Spring Data Neo4j and kind of the integration that's there already, that's in production, that customers are using, that developers are using. And then we're going to look a little bit at what's coming and kind of the future of where things are going. So we're in beta versions right now of Spring Data Neo4j Reactive, which we'll talk a little bit about what that provides and how that's different. So that's kind of what we're going to cover today. And there will be code involved with this, so you'll see the differences there. So just high level Spring Data, hopefully most of you are probably familiar with what Spring Data is. But it just allows you to connect to a variety of data sources out of the box. So anything from relational, from document, key value, graphs, etc. And it just kind of allows you to just unplug and replug into the next thing. There's a lot of consistency across the data sources, which is superb. I did a little bit of an experiment not terribly long ago where I took MariaDB and MongoDB and then Neo4j, and I built applications for each one of those and tried to look at what's different in the application. To be honest, there's really not that much, which is awesome for us as application developers. With Spring Data, you get out-of-the-box repository and custom object mapping. Really nice to kind of plug and play there. And there's some dynamic query derivation, which Spring handles kind of behind the scenes for you. If you have some basic methods, those are provided out of the box, and then others can be derived based on your method names, which we'll take a look at here in just a bit. Not only that, but you also get domain-specific language for custom queries. So if you want to write a custom query, something very specific for the database you're dealing with or the data set you're dealing with, you can do that using the @query annotation. And Spring provides you the ability to use the domain-specific language for the database you're working with. So for instance, with Neo4j, you can write Cypher queries. If you're dealing with Mongo, you can write SQL or JSON queries, believe it or not. Something like MariaDB, you can write JPQL, Java Persistence Query Language, or SQL, etc. So really nice capabilities there. With Spring Data Neo4j, that allows you to connect to Neo4j, of course, which is a graph database. This integration is actively developed and supported by both Spring and Neo4j teams. Really great partnership going on there. And right now, it comes in two different flavors. So we have a Spring Data Neo4j, or what we have kind of shortened to SDN, which gives you the ability to do standard imperative applications. And then what's coming, which is Spring Data Neo4j Reactive, SDNRX, we've kind of shortened that as well. That's in beta phases right now. And that gives you the ability to write both imperative and reactive applications on that. And we'll take a look at those here in just a second as well. So just quickly, for those of you who may not be familiar with Graph, a very quick overview on what the data is going to look like, some of the terms I might be throwing out today in the next several minutes, and just so you're familiar with those and don't get lost, basically. So graphs basically show data as connected structures. They're basically like networks. That makes it really easy for humans to read and visualize because you're storing almost physical joins, basically. So instead of doing those joins on query time, you're actually storing them in the database. So you get that more network picture that you see on the right-hand side of the slide. It allows us to visualize it and to analyze it really well. You can pull relevant data. You can also pull a variety of data. So this is really, really helpful when in traditional relational models, you're dealing with tables of thousands, millions, billions of rows, and you're doing 5, 6, 7 table joins. That gets really complicated, really cumbersome, and the queries might have some performance downgrades. Where in a graph, with those physical relationships, you're able to pull that relevant or varied data very close to the piece of data you're interested in. And therefore, that small little network that it pulls makes those queries, those types of queries, a lot faster. And again, works really well visualizing data. There's tons of vendors and tools out there for data visualization for graphs as well as other types of data structures. But this type of network structure lends itself well to visualizing. So in case I do throw out some terms, graph at its core is all about the relationships between your entities. Neo4j uses the property graph data model. There are a couple other data models out there, but in case these terms, I might throw these out here. So if you're not familiar with those, the big things that are kind of important about Neo4j are nodes, which are your entities or your objects in the data, and then your relationships. So those connections between your entities. Labels are just a way to kind of categorize or tag your entities, and then properties are the attributes on either your relationships or your entities themselves. So those kind of terms I may throw out. I'll try to temper that just a little bit, but just in case. Okay, so this is the actual data that's sitting down in my database. When we write our application to interact with this, this is the data that it's interacting with. So we're going to kind of focus in on the centerpiece of that, which is the comic issue entity. I'm using the Marvel data set, Marvel Comics. And so we're looking at Marvel Comics there in the center, and we're really going to focus on that includes relationship that goes from comic issue to the character there on the right. So that's the application we're going to build. We're going to pull those two entities and the relationship between those. However, there's other entities that sit down in that database that I have, just so you're aware. Okay, so why would we choose Spring to do something like this? Why would we want to build an application in Spring on top of Neo4j or any other type of database? One, it's very widely used. It's very easy to get up and running. Spring Initializer gives you a great way to just create a project out of the gate and get something going. Spring Boot reduces quite a bit of boilerplate for you. I mean, who wants to sit around and write all of that custom boilerplate every time you go to build an application? Whether you're dealing on an individual level or an enterprise level, it's a lot of stuff to maintain and to edit or to create every time. Annotation-based OGM, or if you're used to dealing with relational databases, ORM, Object Relational Mapper, for your plain old Java objects. In this case, it's OGM, Object Graph Mapper, for your graph objects. So you can use annotations to handle those and to map those, which is really nice. And then Spring Data connects really well to Neo4j via the Bolt protocol, via HTTP protocol, or via embedded mode as well. So it makes it really nice to work with Neo4j, which is kind of these things out of the box. So this is the project page. If you're curious to know more about this integration project, the Spring Data kind of high level project there, and then Spring Data Neo4j is one of those sub levels. So there's documentation there, there's examples, there's a little bit more about the integration itself, all on that page. And then of course, the other thing that's really nice is this is all out on GitHub. So that project is stored out there. You can submit pull requests or issues or give us feedback on that. Again, this is housed under the Spring GitHub section. But feel free to reach out to us as well. There's a good partnership going there as far as updates and work going there. Okay, so let's stop here and let's look at some code for this. So we're gonna start off with our first project. So I guess I want to show how I did this in Spring Initializer. It's pretty straightforward. So I just went to the basic start.spring.io. I'm using all the defaults, and then the only dependencies I need to add for this are Neo4j and the web dependencies. And then I can just generate and download that. Comes in really nicely, nothing else fancy going on here. No big things being set. So if we look at the POM here, you can see there's my Neo4j dependency, Spring Boot starter data Neo4j, and then the web dependency that I had in there as well. And there's nothing else going on in this one. So really basic, straightforward. Now, the only properties that I need are basically my database credentials. So I just need to tell it the username and password to be able to connect to my database. And that's pretty much it, just your kind of standard out of the box properties here. So with that, let's dive in and look at our entities. So we're going to build, I mentioned earlier, we're going to build our characters and we're going to build our comic issues. And then we're going to look at the relationship between those. So here we have our annotation for @node entity saying that this is an entity type for our application. And because Neo4j uses nodes, it's being defined as an @node entity. If you're dealing with documents, it's @document. If you're dealing with relational tables, I believe it's @entity, just plain @entity. So yeah, pretty standard if you're, depending on the data model that you're dealing with. So we have a generated ID value here, and then we have 3 member variables: a character name, a character description, and then an image file. And then I'll come back to the relationship in just one second. But just the standard entity here. So our empty constructor, our argument constructor, and then all of our getters and setters. Now, I'm going to go over to the comic issue and kind of show that, and then I'll walk through the relationships here. So same thing happens here. We have our @node entity. We have a generated value for the ID. And then we have a couple of member variables, one for a comic issue name and an image file. Then we're also going to look at the page count, the number of pages inside that comic, and the issue number. The data set that I have calculates the issue number as a double. I'm not quite sure why that is, but that was how the data was formatted when I pulled it in. So we're going with that. And then again, I'll come back to the relationship in a second. Our empty constructor, our argument constructor, and then all of our getters and setters down here. So now let's look at these relationships, because we know we have 2 entities, a character and a comic, and then we have that relationship that goes between them. So when I pull characters, I want to find out for a particular character or all particular characters, what are the comics that they're involved in, that they're included in. So here I'm going to expect you could have a list of multiple comics that a character is involved in. For example, somebody like Iron Man or the Hulk or Captain America is probably in a lot of comics. So we're going to get a list potentially back here and call that character comics. We need to define this again with an annotation. So that's one thing that's really nice. Just say this is a relationship entity here, our relationship connection. And here's our relationship type. So Neo4j uses types to kind of quantify or qualify what the meaning of the relationship is between entities. In this case, we've named it includes. You may or may not recall, our comic issue will include a character. So the character is on the receiving end of that relationship. And so we just specify a direction of incoming for that. I'll come back in just a second to this JSON ignore properties. Let me go show the comic issue side. So same thing on this side. We're looking at an relationship, type includes. This one is outgoing because we're from the comic issue, we're going to character, so we don't have to specify direction there. We're expecting a list of characters because a comic issue could have multiple characters involved in it. And we're going to specify a member variable there as well. Now, when I go between these 2 entities, I'm going to follow the relationship. When I pull characters, it's going to go out and look for the comics that those characters are in. And when it goes out to the comics, it's going to grab all the member variables of comics and go back to character. Notice one of our member variables of comics is characters. So it's going to go back to the character entity. And when it goes back to the character entity, it's going to pull all the member variables of character entity, which guess what? Goes back to comic issues. And you get this really ugly infinite recursion error message that's really hideous. And so what we end up having to do is it could traverse that relationship, that bridge between these 2 entities forever and ever and ever. And so we don't want it to do that. We want it to stop at some level. So when we're coming from the character side, we want to say we're going to pull all these variables. And when you go over to the comic issue to pull all the member variables of comic issue, we want you to ignore the character variable, which if we go over here, guess what? Characters, we're going to ignore this one, which means it's not going to go back to that character entity. Same thing's going to be on the other side here. We're going to stop it and say, when you go to the character entity, don't pull character comics, which happens to be this variable right here. So it's going to avoid that traversing across, back and forth across that relationship continuously and ending up with that really ugly error message. Okay, so now let's look at our character repository. Pretty straightforward out of the box here. Not very much code that we need to add, which is nice. So we have an interface for character repo. We're extending the Neo4j repository, and we're including our entity type as character, the ID type is a long, and then I mentioned that Neo4j, or not Neo4j, Spring provides some entities for you out of the box. Things like find one, find all, those sorts of things are just provided because those are pretty standard methods. But then if you want to specify anything else, you can draft up your methods. So here I'm just doing a very simple get character by name. So if I want to search for a particular character, I might pass a name into my parameter string, and then it will go and see if it can find that character name in my database. Return hopefully a single character out of that. And so I'm defining my method there. Now, if I want to look at my character controller, defining a REST controller and setting up our path, our URL path of /characters. So there's my REST endpoint that I can hit to get all of these methods here. I'm injecting my repository and then setting up my methods. So I have a find all method. Remember, I did not have to define this in my repository. This is one of those methods Spring provides to me out of the box. And I am expecting multiple characters to come back because it's probably going to be a massive list of characters in my database. So we're getting an iterable of characters back, and I just do the character repo.findAll, and that should be everything that I need for that one. Then I'm going to set up an additional endpoint where I can pass in a character name path variable and get hopefully a character coming back. So there's my get character by name that I did set up in my repository class and pass in the name along the path, and then call my character repo and implement that method passing in the name variable. So that looks pretty good. Now what about on the comic issue side? Let's do our comic issue repo. Same thing goes here. We've got an interface comic repo. We're extending our Neo4j repository with our entity type and the ID type. We're expecting a comic issue type coming back for our get comic issue by name. So I want to, again, find a specifically named comic issue. I can do a search on that, pass in that name, and hopefully retrieve that from the database. Again, my find one, find all methods provided for me out of the box. I don't have to specify those here. Let's go look at our controller. Set it up as a REST controller, define our endpoint at /comics. So I can, at that endpoint, I can attack all of these methods then, inject my repository, and then set up my find all method. So I might want to find all my comics as well in my database. So expecting multiple comics to come back, implement the find all, comic repo.findAll. Again, out of the box, nothing fancy there. And then specify where I can pass a name variable along the URL, and hopefully find a comic issue coming back with my path variable, hitting my repository and implementing that method that I defined. Okay, so with that, and I showed the application.properties, with that, I think we are ready to start this and hopefully show something. Okay, everything looks good there. Let's go back over to our tab here, and we're gonna attack this endpoint. And let's pull all of our characters. I have a little formatter in my browser that makes it look pretty. So we have our characters, a list of characters here. In this case, here's one of them, Abomination. There's no description for him. We do have thumbnails, and if we click that, oh, that one's not found. That's no fun. And then hopefully a list of comics, which this character does not have any comics assigned to him. That could be a data issue. I'm working on solving some of that at a later time. But if we skip down here to The next guy, we have Absorbing Man as our character. We have a thumbnail for him. Let's see if this one works. Ah, that's better. Ooh, that's pretty intimidating. And we have a thumbnail for him and all of his character comics. So his comics are actually coming back. So we know that that relationship, traversing that relationship and pulling those comic entities on the other side is working. We're getting all of the details back for that. We're getting comic JPEGs. So he was apparently in a special, Valentine special, etc. And we can go down on through the list and we're getting a bunch of characters coming back and a bunch of comic books that are attached to those characters. So now let's go from the other side. Let's pull our comics and it'll format this really pretty for us, hopefully. There we go. And so we get our X-Men comic here. We have a thumbnail for it. We have a page count and an issue number. And then we have the characters that are involved in that comic. So in this case, we have Bishop and Angel. There's some more X-Men comics down here with other characters involved and all of that. So our find all methods then are working really well. What about the ones where we want to search for something in particular? You can see I've kind of done this before. My favorite superhero is Captain America. So we can do a search for him and see that, yes, as far as that find, get character by name method that I defined, I am able to search for a character name and get Captain America. I get his description. I get the thumbnail for him coming back. That's looking good. And I get the comics that he's involved in, which are quite a few. So that's a good list. Now, what about our comic endpoint? What can we search for a particular comic? So at this, I'm going to search for just one in particular. And yeah, Secret Empire. And so we get our comic coming back. We get the thumbnail for it. We get the page count in the issue and the character, which in this case is just Captain America for this one. So all of that's working and looking really good. We've got just our basic REST endpoints working and functioning. It's pulling data from Neo4j and formatting that for us, and everything looks good there. So let's go ahead and stop that one. Now let's switch gears just a little bit and we'll go reactive. So let's talk a little bit about the reactive capabilities and the reactive project here. So if you're not familiar, reactive basically provides ability to control the data flow and the volume of the data coming back and forth between your client, or to and from your client. And it allows you to add some back pressure to say, I only want so many results at a time, or I can only handle so many results at a time before the application keels over. And so it allows you to kind of maintain that control over how much you're getting. It may or may not boost your performance. Don't necessarily go into this thinking, I'm doing this for performance benefits. Sometimes it can if you're parallelizing those requests. But really what it's actually doing is it's allowing you to scale and handle that workload better and manage that. It might actually prevent your system from overloading and collapsing. So, and allows you to kind of scale the ability to handle those things up and down as needed, which is really nice. There are tons of implementations on Project Reactor. Spring is one of them. It's an excellent integration for that. But Project Reactor is more of a core foundation and principles on that. There's some niche implementations. There's all kinds of other integrations as well. Spring is just one of those, and then Neo4j has taken that Spring integration and built that onto Neo4j as well. So that's really what we're doing here. Things that are specific to our SDNRX project. So we have both imperative and reactive support. So if you want to develop a typical standard imperative application, you're more than welcome to do that with the SDNRX project. You can also develop the reactive capabilities. And all that it's doing is implementing the publisher type of Project Reactor so that you get the mono type, which allows you to take a 0 or 1 elements, or a flux type of 0 or n elements. And the code for this actually looks pretty similar to the Java Streams API. If you're familiar with working with that, there's not a ton of difference. So it looks very similar. With the SDNRX, we've unified our Spring Data Neo4j and the object graph mapper layers If you're familiar with the SDN before, those were two separate layers, the object mapping and then the actual application Spring Data Neo4j layer. That got kind of confusing figuring out what handled what sometimes. And so with this, we've kind of bundled those, and the SDNRX project is working directly with the data at the raw driver level, which I'll show in just a second. We also, if you're using Neo4j already, we do offer conversion and Neo4j type support. So the data types that are available in Neo4j, SDNRX supports those. And then Spring 5.2 Reactive Transaction Manager. I'm not sure how many projects support that at this time, but the SDNRX project does. So this is kind of the diagram for the architecture of the SDNRX library. So we have that Java driver level at the bottom that you can see on the left-hand side. And there's a starter dependency there on the right for the driver. And then on top of that is bundling the different components or modules of the SDNRX. So we have a Neo4j client, a template, and the Spring Data repositories. Now both of these are available for the imperative or the reactive. So you have the Neo4j client template repositories for your imperative, and then we also have a Neo4j reactive client, reactive template, and the reactive repository on top of that. So that allows you to kind of handle both those things in that starter. So that's kind of the architecture for that. This does live on the Neo4j side right now. It's not part of the release for spring. We're hoping it will be at some point, but right now it just lives over on the Neo4j side. So this is where you would find the code for that. It is open. Feel free to submit issues or pull requests there as well if you're using this or want to try it out. We're more than happy to take feedback or questions on that too. Okay, so let's look at the code for this now. So there's a little bit of difference here. And actually, let's look at how we fire up the project in Initializer. So the only thing that I need, because our SDNRX, the reactive Neo4j project, is not part of the dependency library in Spring just yet, we can't add it in our Spring Initializer, but we can go ahead and add the reactive web component. So we're going to use that as a dependency, and then go ahead and generate the project, and then we'll just need to add our SDNRX dependency here. So see, there's our reactive web, our web flux artifact that we pulled in from our Spring Initializer. And then the only thing I had to add were these two dependencies here for the Spring Data Neo4j RX Spring Boot Starter. And because it's not a GA release just yet, you'll have to specify the beta version for now. And then same thing for the test library here. So those two dependencies are the only thing I needed to add. Everything else, standard out of the box, same as what we did with SDN, really just the different Spring Data Neo4j library. Application.properties, there's a couple of small things. So the username and password is exactly the same. I need the credentials. It allows you to work with both a replicated cluster or a single instance. And because Neo4j is in the midst of upgrades as well, we've got a couple of different versions we support that provide some drastically different capabilities. We had a major release a few weeks ago. And so right now, the SDNRX library requests that you have the URI defined. So that is one thing that's different between SDN and SDNRX, at least for right now, is you'll need to specify that driver URI. And then we also want to tell it, we want to take advantage of the reactive repositories. So I'm going to specify this application.properties because I want to use the reactive capabilities in the RX library. Okay, so a few very, very minor differences in our entities. First of all, our annotation is slightly different. It's an @node rather than an @node entity. Condensed it just a little bit, shortened it. We still have our generated ID. We still have our member variables here. And we still have our relationship going over to comic issues to grab the comics that a character is involved in. So nothing really there has changed. Constructors, getters and setters, all the same. Our comic issue entity, pretty much same thing here. We have our @node annotation instead of the @node entity. We have our generated ID, our member variables, the relationship going over to pull the characters for a particular comic, our constructors and our getters and setters. Nothing new. Okay, so now let's look at our character repository. Very little has changed. We're going to say this interface character repo. We're going to extend the Neo4j reactive repository. So again, we want to use those reactive capabilities. We need to have it extend that reactive repository. So doing that there. And then we still have our get character by name. We want to search for a particular character by a name that we want to pass in. But we're going to use a type mono coming back. So we're expecting 0 or 1 entities to come back from this. And so we can specify this mono type of type character to set up our method there. And then if we go back and look at our controller, again, REST controller, set up our endpoint here, inject our repository in these lines, and then we want to set up our find all method. This is really where the bulk of the difference comes in. So we're setting up our mapping. We're going to produce a text event stream media type, which I'll talk a little bit more about that and what that means here in just a second. And because we're doing a find all, we're expecting multiple entities to come back. So we can't use the mono type. We're going to have to use the flux type, which allows 0 to n entities coming back, so multiples. So a flux of type characters, get characters, we're going to do a find all. And here's where I'm adding just a little bit of back pressure. So I want to say for my application, I only want to get 1 entity or 1 result from the database, 1 every second. So I'm going to kind of add a little bit of back pressure there to make sure that we don't overload my application. And then I can set up my get character by name, pass in the name value. I'm expecting a single result or 0 results to come back, pass in that path variable, and implement my method from my repository. So that's looking good there. Now let's go over and do our comic repo. Looks the same as what our character repo did. So we have an interface, extends the reactive repository. We're expecting a mono of comic issue when we search for a particular comic and pass in our name. And then if we look at our comic controller, we have our REST controller, set up our endpoint, inject our repository, set up the media type that we're expecting to come back. We're expecting a flux, multiple comic issues to come back when we do a find all, and then setting up just a little bit of back pressure here so we don't overload and overwhelm our application. And then of course, the comic issue, expecting a mono type to come back, passing in that path variable that we're gonna feed it a comic issue name, and then implementing the method from our repository. Okay, so with that, yes, I will talk to the media type here in just a second. I haven't forgotten. So we'll go ahead and run this and show. So let's support 8080/characters. And you can see we scroll there and we're getting 1 per second. So it's feeding, because we're listing all of the comics that a character is involved in, it kind of feeds every so often. When you have no results, it's kind of a short request here, but as you can see, there's some that have several comics involved there. Now notice that this is not pretty. It's not pretty printing for us. And that is because of that, that text event stream that we set up as our media type. If we look at the /Captain America, notice that that is pretty printing, which took me a double of a time to figure out. But we have our Captain America, his description, all of the comics that he's involved in. So why would that be different? And if you do the same thing for comics, if we do our find all method, we're getting that 1 per second, but it's not pretty printing. It's just flat text, which I mean is okay. It's just not maybe what we were expecting. Whereas when we do the /Secret Empire, look for a particular comic, we're getting those results back pretty printed. Now, the reason for this is that we have specified this text event stream. Now, you can do it where to format JSON, which is what I did over here. So if I comment this out and I uncomment this, this will allow us to format JSON. But what's interesting and something to be aware of, okay, that's looking good, is when I try to refresh then and go back to characters, it's just going to sit and spin. Why? Well, if you remember what was showing in my code, I had here where I still have some back pressure defined. So I'm telling it I only want to pull one entity every 1 second. And with JSON, it's going to wait and append each one of those entities to my JSON object and wait for all those entities to come back before it displays them to me. So if I have 1,400 characters in my database, or 2,000 or however many, it's going to wait and append each one of those one every second, so 1,400 seconds in this case, before it appends everything to that JSON objects and then dumps it back to me in the browser. So this is where back pressure, you need to make sure that you align. First off, I don't want, if you want to wait for that full JSON object to be built and then returned to you, that's great. But then beware that you may want to watch how much back pressure you're adding. So this, it's going to return server-side events, SSE, which is a text event stream, which then allows you to do that back pressure and to only retrieve each single entity at a time and just dump that individual entity or 5 entities at a time, et cetera, and just dump those straight to your browser or wherever you happen to be consuming them. So that is one thing to keep in mind there. We rerun this now with our with that back in place where we're doing that text event stream. Let me go back over here and try to hit this endpoint again. Notice we have this coming back. Our back pressure is working. We're getting 1 per second, and it's sending those results to us. So we're back in business. So that took me a little bit to kind of figure out. It is a little bit different, something to kind of keep in mind. So with that, I want to leave you with just a few resources. So the source code is out there for the applications that I showed and built today. So feel free to have a look at those. These are pretty basic, no fancy UIs or anything on top of that. The Spring Data Neo4j information, repository, documentation, all of that's available on the Spring side. So if you go out to spring.io, projects, Spring Data Neo4j, all of that is there. Neo4j has some stuff too, but the core of the documentation and everything's out on the Spring stuff. The Spring Data Neo4j RX, that's all out on GitHub on Neo4j's side. There is documentation and examples and everything in that GitHub repository, so you're not kind of left to fend for yourself. There's information out there for that. It just doesn't have its own project page just yet. And then please do feel free to reach out to me, contact me on Twitter or email or however you're most comfortable. And so I will stick around and monitor the chat if you guys have questions. Thank you guys very much for listening, and hope you guys enjoy the rest of the conference.
Well, thank you, Jennifer. I do appreciate your presentation. That was awesome. So folks, wander over to the QA section, and she will be present to answer questions. So feel free to ask away. But we're going to go ahead and roll right into no breaks. We're going to keep it going. We're going to be talking to Thomas Reisberg. Thomas, you ready?